So we are going to talk about Riemann sums. So I have the graph of the function g of x, and we are going to approximate the area under the curve on the interval from 2 to 6 with 4 subintervals. All right, so we are going from 2 to 6. That looks bad. Hold on. All right, from 2 to 6. All right, so we're going from 2 to 6, and the 4 subintervals is talking about the number of rectangles. So we're going to have four rectangles, which kind of makes sense because you're going to have them kind of like this. All right, so 1, 2, 3, 4. So to determine the height of these rectangles, we are going to use the left point because this one is asking for the left rectangular approximation. So I'm going to start on the left side, and I'm going to use the left point to determine the height of my rectangle. So this first rectangle is going to be about that high. The second rectangle is going to be about that high. This one is going to be about that high. And this one is going to be about that high. And so if I total up what the area of these rectangles are, it would give me an approximation of the area under the curve. Now looking at your area and your shape, do you think this would be an under or an over approximation?
Under.
It's an under.
Yeah.
Because your rectangles are under your graph.
No.
That's all that means? Like if it's under the graph or over?
Mm-hmm. Yeah. And we're going to get to the point where we're actually going to total up the areas. But we have lots of examples, so we'll do that in a little bit. All right, so on example 6, it's the same exact thing. We are going to take the interval from 2 to 6. We are going to have 4 subintervals, so still 4 rectangles. But now we're going to use the right point to determine the height. So I do think it's easier if you use the left point, start on the left and work your way over. If you're going to use the right point, start on the right and work your way over. It kind of just helps drawing. So I know that I'm going to start here and I'm going to use this guy as my right point. So that's my first rectangle. Then for this rectangle here, I'm going to use the right line. So that's that rectangle. This guy right here, I'm going to use the right line. So it's that rectangle. And then this guy right here, I'm going to use the right line. So it'll be that rectangle. So if you added up the areas of all these rectangles, it would give you an approximation. Would it be an under or an over?
Over.
Over, because your rectangles are over your line.
That makes no sense.
Woo. Okay. So the approximation method that I just kind of drew out for you is called a Riemann sum. It was named after the German mathematician named Bernhard Riemann. All right. The first thing you're going to want to do when you are calculating the left or the right Riemann sum is figure out the width of your rectangles. And that is determined by how many rectangles I want or how many subintervals. All right, so once again, this guy right here is the number of rectangles. All right, so number of the number of sub-intervals, which in this case we're using n, is the number of rectangles. B minus A is your starting and your ending point. So if I want to take the interval from 5 to 8, you would have 8 minus 5 divided by however many sub-intervals I have. And that would give me the width of each of my rectangles. In situations where you have a table of values with specific points, the widths are not always the same. So if you don't have to actually flip, but in this case right here, the widths are not always the same. Now I know on this example, they are the same, but not always. So if you look at your homework, where's one on your homework? Here we go. On this one, what would be the width from 0 to 4? 4. What about from 4 to 10? 6. So your widths are changing. So you have to kind of watch out if you're given a table of values, your widths are not always going to be the exact same. So you only can approximate with the information that's given. Okay. And there are 4 different kinds of Riemann sums that we learn in calculus. You have the left and the right, which we already drew. So you have the left Riemann sum, the right Riemann sum. You also are going to have the midpoint Riemann sum, which is just like it sounds. It would find the height would be determined with the midpoint. And then also the trapezoidal Riemann sum, which is why knowing the trapezoid formula is so important. The trapezoidal Riemann sum is the best approximation because it's going to give you the least amount of area either under or over. And you'll see because I'm going to draw them out. Okay, so let's actually calculate one. It says below is the curve of f of x equals 4x minus 1/2 x squared. Use the Riemann sums to find the approximation of the area under the curve from the interval from 2 to 8 using 3 sub-intervals. All right, so I'm first going to figure out the width. All right, so the width of my rectangles is going to be 8 minus 2 divided by 3, which is going to be 2. So the width of my rectangles is going to be a length of 2. So when I'm drawing that on my graph here, I'm going to start at 2. I'm going to end right here at 8. And so my rectangles are going to be a width of 2. And so if you kind of draw out the lines here, you can see you've got 3 of them. All right, so on this one, I want the left Riemann sum. So I'm going to go from left to right, and I'm going to draw my rectangles. So there's my first one. You use the left point to determine the height. So for your second rectangle, we're going to use the left point to determine the height. And then your third rectangle, you're going to use the left point to determine the height. So we are going to figure out the area of each one of these rectangles and we're going to add it together. So the first rectangle, base times height. The base is or the width is a length of 2. And how tall is that first rectangle? 6. So the first rectangle is going to be 2 times 6, which is 12. The second rectangle is going to be still 2 times 8, which is 16. And then the third rectangle is going to be 2 times 6, which is 12 again. And so when you add up the area of all of the rectangles, that will give you an approximation of the area under the curve using a left Riemann sum. So the approximation for this example here is 40. Which you can kind of tell from looking at the area that's over versus the area that's under, that it's probably going to be an over approximation because more of it is on top. Does that kind of make sense? All right, so let's do the same thing. We're going to do a right Riemann sum. So to find the width, it's going to be the same thing on really all 4 of these examples. It's going to stay 2. All right, we're still going to take this from 2 to 8.
Excuse me, may I have your attention, please? Teachers, please release the JV and the varsity girls basketball to the locker room. Thank you.
Okay, and so now we are going to do the right Riemann sum. So I think it's helpful when you're drawing your rectangles to start on the right side, but you don't have to. On this one, if you start on the right side, what is the height going to be? 0. So really this first rectangle, it's at 0 because the right point is at 0. Now the second rectangle, what's your height going to be at? 6 because the right point is over here at 6. And then this last one here, 8. All right, so your this first rectangle here, base of 2, height of 8, which would be 16. Second rectangle here, base still is 2, height is 6, which would be 12. And then your third rectangle, the base is 2, but your height is 0, which would be 0. And so your approximation, 6, 7, 8, is going to be 28. So you can kind of tell that this one is going to be an under approximation because of how much holes you have underneath your graph that we haven't really accounted for with our approximation. All right, so you've got your left, you've got your right. Now we got to try. Hello? Yeah, sure. Okay. All right, so now we're going to try midpoint and trapezoid. All right, so if you notice, it's the exact same graph. We're going to have the same intervals from 8 to 2. So your width is the same way. 8 minus 2 divided by 3, which is going to be subintervals of 2. Hold on, I'm getting my posters laminated. Alright, so I'm going to draw my little rectangles here. So I'm going from 2 to 8, and they're width of 2. Alright, now for midpoint Riemann sums, the midpoint is going to determine the height. So on this first rectangle, not the left, not the right, but the point in the middle is going to determine how high you are. So it's going to look something like that. You see how that middle point determines how high your rectangle goes? All right, so from 4 to 6, the point 5 is going to determine how high my rectangle goes. And then from 6 to 7, the point 7 will determine how high my rectangle goes. All right, so we're going to total up the rectangles here. So we've got the first rectangle, which is base 2, height of about 7.5, which is 15. Rectangle 2 is the same thing, base 2, height of 7.5, which is 15. And rectangle 3 is base 2 with a height of 3.5. Right? Yeah, which is 7. And so when you add all of that together, you get 37. Which is a closer approximation to the area under the curve. You have a little bit mixture of what's on top and what's underneath. Now the closest approximation that you can have is a trapezoid. in this case, you're still going to do 8 minus 2 divided by 3. But with trapezoid, that's not going to give you the base. That's going to give you the height of your trapezoid. Does that make sense? If you were to draw that out? Okay. Well, I am going to draw it out. So here's 2 to 8, and then we're going to draw the trapezoids. So we got one at 4, and we're going to draw a little diagonal line. One at 6, draw a little diagonal line. And then this one's going to end up just being a triangle because that other guy is all the way down there at 0. So if you look at the trapezoid, this length right here is your height of the trapezoid, where the 2 sides are the bases, because they're the parallel sides. So when you total up your area, trapezoid 1 is going to be 1/2 the height, and base 1 is at 6, base 2 is at 8. Which is going to give you 14. And trapezoid 2 is going to be the same thing, 1/2 your height, which is 2, and then your base, which is 8 plus 6. So those are the same shape. And then the last one, which is really a triangle, you could think of it as another trapezoid if you want. Your height is still 2. Your base is 6, or 6 plus 0. You get the same thing. And so you'll end up with just 6. And so you can even see from your picture that this is the smallest amount of empty space that we haven't included. So it'll give you the closest approximation, and the area under the curve is going to be about 34. All right, so you can kind of see, looking at all 4 different ones, the left Riemann sum is 40. That's the over approximation. 28 is your under approximation. 37 is really, really close, and 34 is the closest. Thank you. All right. Y'all still good? Doing okay? Hanging in there? All right, over and underestimate. This is going to go by kind of quickly. This is not something I generally memorize, but instead I draw a picture to visualize what's happening. You have so many things to memorize already in calculus. This wouldn't be one of the things. I would honestly just sketch it out. So if you are increasing and you have a left Riemann sum, so the left point is determining the height, is that an under or an over? Under. So see, if you sketch it out, it makes it pretty obvious what's happening. If you're increasing and you have a right Riemann sum, so the right point is determining the height, is that under or over? Over. Okay, so let's talk about decreasing. If you are decreasing and you have the left point determining the height, under or over? Over. And if you are decreasing and you want a right Riemann sum, under. All right, you're welcome to memorize it if you want. I normally just draw a picture and then use whether increasing or decreasing to justify my answer. All right, let's talk about trapezoids. They might ask you about trapezoidal estimation, but that deals with concavity. All right, so if you are concave up and you were to try to draw a trapezoid, are you under or over?
Under. Over.
It's like, it's really hard to see, but there's like a sliver. If you draw, sometimes it helps if you just draw the triangle. Like you can kind of tell like you're going to be over. And then this one, if you drew a triangle with your x-axis, you would be under. All right, I'm going to make some edits here to these next 2 questions. I want to turn this into a trapezoid Riemann sum, and I'm also changing the function to be a little bit easier. I want to change it to negative x cubed minus x plus 11. Okay, so I want to approximate the area under the curve using a trapezoid Riemann sum for this function right here with 3 subintervals on the interval from -1 to 2. All right. You might like drawing a graph or you might like drawing a table. I'm kind of more of a table person. So I know I'm starting with my table. I'm going to start with -1. And then I'm going to go 0, 1, 2. All right. And I'm going to figure out what the height of my trapezoids are going to be by doing 2 minus -1 over, and I want 3 subintervals. So 3. All right. It's the width slash height. The width if you're talking about rectangles, the height if you're talking about trapezoids. And so what is my height going to be of each one of my trapezoids? 1. So if you think about it, we're going to have this guy be a trapezoid because it's going to be a width of, or a height of 1. This guy is going to give you a trapezoid, and this guy is going to give you a trapezoid. And they're all going to be a width of 1. Does that make sense? How would you figure out what the bases are going to be?
Your x.
Yeah, your f of x. All right, so you're going to plug it into this formula right here, just for the sake of time. 13, 11, 9, and 1. All right, so when you plug -1 in, 0, 1, and 2, that's where I'm getting those green numbers from. And once you have those green numbers, you have everything you need to figure out the trapezoidal Riemann sum. So for your first trapezoid, it is going to be 1/2. What's the height? 1. What's one of my bases?
13.
13 plus, what's the other one?
11.
11. All right, for trapezoid 2, 1/2 times 1, what's one of my bases?
11.
Plus.
9.
And trapezoid 3, 1/2 times
1.
times
9.
plus.
1.
Yep. And so then that's going to be 12, 10, and 5, which gives you a grand total Riemann sum of 27. Does that kind of make sense? All right, for the next one, instead of doing a left, because we've already done left a couple times, I want to do a midpoint. And instead of making this 5 subintervals, because that's kind of a lot, we're going to make it 2. All right, so same thing. I'm kind of a table person. Visually, that works in my brain. If graphing works better in your brain, graph. And so I'm going to list my interval numbers. I'm starting at -2 and I'm going to go to 2. So -2, -1, 0, 1, and 2. So that's coming from my interval numbers right here. All right, so that's kind of how I know what x values to use for my table. For my width of my rectangles, because this is a midpoint, so for my width, I'm going to do 2 minus -2 over, and I want 2 subintervals, so over 2. All right, so 2 plus 2 is?
4.
Divided by 2?
2.
So my width is going to be 2. So that's going to be one of my rectangles, and that's going to be other. They are going to be a width of 2. So it's not going to be 1, it's going to be 2, so you got to span a length of 2 numbers. Does that make sense? If I want the midpoint I need to figure out what the midpoint value is. I don't care about the left and the right. All I care about is the midpoint. So I need to figure out what this number is and what this number is, because that's what's going to determine the height.
-1 and 11.
Yep, so -1 and 11. So your first rectangle is going to be a base of 2 with a height of,
-1,
and then your second rectangle is going to be a base of
2,
with a height of,
11.
so -2 and 22, which gives you a grand total of 20 for your Riemann sum. Okay, we're almost done. All right, now we have a table, which is nice because it gives you all the values. Tables are always really nice. The rate at which water is being pumped into a tank is given by the continuous and increasing function r of t. A table of selected values of r of t for the time interval from 0 to 12 is given below. Use the following Riemann sums with the given intervals to estimate the number of gallons of water pumped into the tank during the 12 minutes. All right, so remember, if you're wanting to figure out the amount of something, you want to accumulate area, and the way you do that is finding the area under a curve. Remember, that's all about the accumulation of the rate of change, and that's going to tell you how much water has been pumped. So on this first one, we are doing a right Riemann sum. And we have 4 subintervals. So that's going to be 1, 2, 3, 4. Because we're given a table, we are not given a function, we're given a table, your widths might be different. So you have to look at your table. Now I think on your homework they're different. On this one, I don't think they are, but just make sure you check. What is the width from 0 to 3? 3. What is the width from 3 to 6?
3.
From 6 to 9?
3.
And from 9 to 12?
3.
So make sure you check if you're given a table. They do not have to be the same. They are in this case. All right, when you are using a right Riemann sum, dang it, we're so close to being done.
That's unfortunate.
There we go. Okay. When you're using a right Riemann sum, you are using the right points only. So you are going to be using this number, this number, this number, and this number. You aren't using 7 because that's a left point. Does that make sense? Okay. So we are going to do 3 times 13 plus 3 times 18 plus 3 times 23 plus 3 times 27. Which is going to give you a total of 243 gallons.
Reminds me of what are they called in pre-calc? It was like a number with an exclamation point. Is it
Factorials. Yes.
That's what it reminds me of.
That's what we're doing right now. We're doing factorials and summations. And this is a summation, and that's going to lead into, we're doing summations in here in a couple days.
Why
Tomorrow?
is the 7 a left point?
Because it's the left number. So like if you were to graph that,
Oh, yeah.
does that make sense?
Today's Tuesday.
Today is Tuesday.
Today's on Wednesday.
What
I was
about
just
you?
preparing for tomorrow.
Got me excited.
Sorry. Okay, so is this a approximation greater or less than the true value? So
Greater.
it tells you that you're increasing. You also can tell you're increasing because of your numbers. So if you are increasing and you are using a right Riemann sum,
Greater.
it's greater. And for the y, right and increasing. That's all you got to put. Right Riemann sum, increasing. That means that it's going to be greater. Okay, so let's look at the left Riemann sum. You're still having 4 subintervals, so my widths are still going to be 3s across the board there because they're all 3s. But when you're doing a left Riemann sum, you're only using the left points. So we are not going to be including 27 as one of my heights because that is a right point. Does that make sense? Okay, so you've got 3 times 7 plus 3 times 13 plus 3 times 18 plus 3 times 23, which is going to give you 183 gallons. All right, and is this a over or an under?
Under.
It's an under or a less approximation because if you drew a picture, you're increasing and you're using left endpoints. So if you kind of drew it out, you would see that you're under. Your reasoning, you would just say left and increasing. Okay, the last two things is I want to use this table and I want to do trapezoid and midpoint. And then we're done. So bear with me, we're almost done. I know this is kind of a long lesson, but remember, no homework quiz tomorrow, and you'll have time to work on your homework tomorrow in class, plus I might give you an extra credit assignment. All right, midpoint Riemann sum with only 2 subintervals. So I'm only gonna have 2 rectangles, which means that it's gonna span a distance kind of like that, where it gives you 2 rectangles. So what is the base of these rectangles?
3.
3.5.
Whatever the middle point is.
6, or the width, I guess. The width is going to be 6. The height of it is going to be
Middle point.
this one, yep, 13 and 23. So midpoint, you would use the point in the center. And they will always, like, if they ask you for midpoint, they will give you a table where it works out evenly, and it will tell you the middle point. You won't have to, like, guesstimate where the point is. Does that make sense? Like, it will work out nicely for you if they ask you for a table. So we've got 6 times 13 plus 6 times 23,
216.
216. All right, so you can kind of see that this is a greater estimation. This is the less than estimation. 216 is somewhere in between those guys, and trapezoidal is going to give us the best estimation of the area under the curve. So now let's do trapezoids. All right, so trapezoids, we've got 4 subintervals, so we're going to go back to doing 4 little boxes here. Now remember, the width of these guys is actually the height of your trapezoid. All right, so 1/2, 3, what's my first base?
7 plus 13.
7 plus 13. The next trapezoid is 1/2, 3.
13 plus 18.
Mm-hmm. And then 1/2, times 3, 18 plus 23. And then 1/2 times 3, 23 plus 27. All right, so 30, 46.5, 61.5, 75. I have to go to the bathroom super bad. Which is going to give us 213 gallons, which is the best approximation of the area under the curve using Riemann sums. Okay, how are y'all feeling about Riemann sums?
It's not that bad. It's good.
Pretty easy.
It's not bad? Okay, good.